Yeah, I know. I'm late. Okay, all right. We're here now. We're here now. That's what's important. We're here now, and that's good. That's good. So yeah, tonight, what are we gonna do tonight? So we got our chess game pretty much locked up, pretty much finished. If you guys had anything you wanted to add, of course we could do that. But I think I asked you guys last week and you didn't. So, I think I put Godot on the thumbnail because I was scrambling for a thumbnail because the thumbnail to go live. So I think I just grabbed an image of Godot and threw it on there. So I guess you guys would probably think I'm scamming if I don't use Godot. So yeah, we should probably dive into some Godot or I'm always down for ranking. You guys know I love ranking. Just easy content and all that. But yeah, we should probably dive back into Godot. Let's see what we have cooking. Is there anything you guys are interested in taking a look at tonight, or should we just pick something random? Because of course we love to do that. One idea I did have is we could throw in a little ChatGPT action and ask ChatGPT for a game that we can make. Yeah, that could be something. Well, I guess it's been taking a look at what I do here because its suggestions include create a content calendar. That's a little suspicious, but I mean I've been pumping information into it for a couple of months, I guess. So I guess that's fair, but yeah, so why don't we just why don't we dive in? Let's see what ChatGPT has to recommend for us tonight, and we'll see what happens there. Now I do have to do one thing right quick. I should probably drop a quick ping in the Discord because I was scrambling to get this stream out, and so I did not get a message in the Discord, so I should definitely drop that off right quick. Let me just drop that. And if you guys aren't on the Discord, I definitely recommend you hop over there. But yeah, for now, we'll hop right into making a game ASAP. Okay, yep, just dropping this in the Discord, and then we should be ready to cook. There we go, nice and easy. Okay, all right, let's see what ChatGPT has for us. Yeah, that should just about do it. So yeah, our strategy is to ask ChatGPT, and let's see how many prompts it takes before we can get a reasonable bite-sized game that we can cook up in 2-3 hours. Okay, so here we are. We have ChatGPT fired up. Let's go ahead and ask it. What is a game I could make in the Godot engine in about 2 hours that would be fun and interesting? Let's see what we have here. Okay, simple endless runner game. That's a fair idea. It's a little stale though, because I have another project idea cooking that's a little bit of an endless runner, so I don't wanna jump on that too early. Let's try another idea. Okay, how about a simple catch the fruit game? That's interesting. Okay, so basically things are dropping from the top of the screen, and you gotta catch them with something you're moving around at the bottom of the screen. Not a bad idea, but Not my favorite. It's up there. It's up there. We'll have it on a list. You know, we'll see. Oh, this is interesting. They've kind of split it in half and given us 2 for the price of 1, so that's kind of hype. A minimalist puzzle game on the left, where the player navigates through a series of interconnected rooms. Okay, each containing obstacles and that doesn't sound like something simple we could do in 2 hours. Let's try on this side. On this side, we have a simple space shooter game. Okay, that seems more promising. We could do, of course, like the classic arcade shooter. If I think that's what this is talking about. Yeah, let's. I mean, honestly, we can dive in with this space shooter idea. Let's just make sure, let's make sure we're not missing out on an idea that ChatGPT has. We'll just ask it twice more. We'll get 2 more ideas, and then we'll pick the best one, which currently is probably sitting at the space shooter idea. And for those of you that are just hopping in, we're just going to be making a game in Godot, and we're asking ChatGPT for ideas for something we can cook up super quickly. So that's going to be the game plan for tonight. And okay, puzzle match 3. So this is Candy Crush. Okay, so that's another option. And for our final option of the day, we will be taking a look at an endless brick breaker game. Okay, that's kind of boring. That's kind of boring. Yeah. So my favorite ideas from it are, I think, we've got space shooter, we've got Candy Crush, and we have catch the fruit. And I think of those 3, we can do a poll if you guys want. But I think of those 3, my preference would probably be space shooter. But let's see what you guys think. Which game should we do? Again, the 3 options are, for the first one, we're gonna do catch the fruit. So that's just like something, not necessarily fruit, but we have something at the bottom of the screen. You move back and forth and try to catch falling objects. 2, space shooter. So that's gonna be like just a classic like space shooter game where some aliens coming down from the top or something, and then we're at the bottom and we're moving back and forth and shooting them. Or the third option is going to be like a Candy Crush type of clone, where we have the little objects and you're trying to make sets of 3 or squares, sets of 4 or something like that. Those are our options for tonight. So we've got a bunch of ideas from ChatGPT. I've narrowed it down to 3. Why don't you guys narrow it down to 1? Or if you guys don't want to, then I'll just make an executive decision myself. Okay, so I think just to keep things moving, I'm gonna make the executive decision to go ahead and move on to space shooter. Okay, no, actually, it looks like catch the fruit is taking the lead. So we'll be doing catch the fruit. So let's this is a pretty basic idea, but it's basically a mechanical idea, right? So we have the mechanical idea. We also need the graphic idea. So if we're doing a catch the fruit mechanical idea, that means the player is going to have something at the bottom of the screen which they're moving back and forth, and their goal is to catch things coming from the top. So our next question is, what are the graphics going to look like? Just because that may we'll of course start with the mechanic, with just simple sprites to get the mechanic across, but we may need to have an idea in mind of what the graphics are going to look like, just in case that changes anything we're going to implement with the basket catching system. So we're going with this catch the fruit idea, but the question is, what should we be catching? What should the game actually look like? And since ChatGPT gave us the idea of catching fruit, we probably don't want to go with that, because if ChatGPT gives you an idea like this, it's probably pretty generic, and you don't want something that generic. We want a unique twist. So we need to think of a twist that we could make while still sticking within the game mechanic. But there's no reason we can't, I guess, get started with the game mechanic while we try to think of a twist. So let's go ahead and create a new Godot project, and we will call it Catching Fruit. And I guess this will be a desktop let's make it compatibility settings. So guys, if you don't know, forward plus is basically desktop, mobile is mobile, and you can also obviously run it on desktop, and compatibility is supposed to be like everywhere, including like the web. So let's go ahead and I just want to select my folder where I keep my Godot projects, and of course you want to hit this create folder button so that it actually adds the folder. Instead of just putting it in your like Godot projects folder, it'll create a separate folder with the correct name, and then put this your stuff that you're making in that new folder. So that's an important option to set, and yeah, that should be good for our project. So once we've gone ahead and cooked up a new Godot project, what we want to do is this looks a little weird. Is it supposed to be off center? I don't know. We want to create a 2D scene because we're going to be working in 2D here, and then let's see. Let's go ahead and create a little bit of a file structure just to get things going. We just need a folder for levels because we need to save our level, and let's just go ahead and call this main. Because you never know, maybe we'll have a main scene and also a menu scene, so it's helpful to move between those. And then we'll go ahead and call the root node of this main as well, just to keep things nice and clean. And yeah, there we go. So it's time. We have our if we hit play, it'll allow us to say that this scene is our main scene, the scene that we start the application on. So let's go ahead and do that, and then boom, this is currently our application. So what we need to do is I should probably end the poll just in case. What we need to do is we need to add functionality so things drop in from the top of the screen, and we can move something around at the bottom of the screen that allows us to catch those things. So, and here an interesting twist could be, I don't know if you guys have seen, but there's a game that's called like Tumbling Tower or something like that, where you basically drop in pieces and you try to build a tall tower. What if the computer drops in pieces, but our goal is to build a tower and to actually have the pieces stand up on each other on our little platform? So picture this, we have, maybe it's even two players, I don't know, but we have our little platform which we're moving back and forth, and the pieces that drop in don't just get collected, they actually just land on our platform. And our goal is to build the tallest tower possible on that platform. I think that's an interesting idea, so let's roll with that for now. Okay, so first we're going to need an object that we can move back and forth at the bottom of the screen. So let's go ahead and add in, what do we need? Probably just a regular node, and then under that we'll add a sprite. Just a regular sprite, nothing too fancy. And then we should be able to add on that, how do we just make it a blank rectangle? A new image texture. That should do the trick, I believe. No, that was not correct. We would like it to be, interesting. We got a lot of options here. Let's make it a canvas texture, perhaps. Yeah, that should do it. Okay, so this is just the visualization of our platform. So we'll call this platform sprite. Or why don't we just go ahead and call this top node platform, and then we'll call this the sprite because we're also going to need a collider. Let's make this a little wider, maybe like a little bit. Yeah, there we go. Okay, so now we have a nice wide platform, and then of course we need a collision so that things can actually land on it, and it can calculate that. Actually, we're going to need a rigid body too. So I slightly messed up this structure. Let's add in a rigid body, 2D of course. And then we want this core node. It can't just be a regular node because we need to do collisions. So this is going to be a rigid body. And then the rigid body is going to have the sprite, which is the visualization, this right here, and then also the collision, which is how it's going to calculate all of the stuff on top of it. And that can just be a collision shape. And then of course, since it's a rectangle, we can just go ahead and select a rectangle. There we go. Now this is quite a big collision shape, but actually I'm realizing this blue outline here, if you guys can see that, it's pretty faint, but this blue outline here is our camera, okay? So this is our world space that we're going to be dealing in. So we actually probably need both of these things to be a good bit bigger. So let me go ahead and make the collision shape maybe 10 times as wide, and we want to unlink these because we don't want it to be the same height. and make it maybe like too tall. Yeah, I think that's pretty good. And then we just need the sprite to actually match that. So just pressing F to focus on this object so we can scale it up properly. Stretch it out. We can just do it with the handles here. Nothing too difficult. Grab the wrong one there. And yeah, we just want to make sure we have a visual component because this collision shape 2D, we can see it in the editor, but obviously we're not actually going to see that in the game. So now we have the visual component and we have the collision component. So let's put that in the center there, and we'll add some code to move it back and forth soon, but I think we first want to test and just make sure we can get some blocks falling onto it and actually landing on it. So make sure we have the rigid body settings correct. And I believe, so we don't want this to fall, so we need to turn off gravity, set this gravity scale to 0, and hopefully that'll let it stay. So then the next thing we can do is we can go ahead and add in, let's actually just duplicate this with Command D, and then we'll call this object. And obviously our objects won't be the exact same shape as the platform because that'd be a little weird, but let's make our object have a little bit of gravity, and let's see it fall. Okay, it falls perfect. Now the problem is our paddle or our basket or whatever this is doesn't actually stay in place. So once again, we may need to change it because currently it's a rigid body, and I believe Godot actually has a static body. So you can make it, this is basically a rigid body, except that it isn't allowed to move, except scripts are allowed to move it, of course. So let's pivot once again and make our paddle a static body, and of course we need to reset our objects to be centered on the static body, and we can move the static body back down. Okay, so now we have a static body. Now this object should fall, and the static body should stop it. Okay, perfect. So there we go. This is the very basis of our game. We've been working for like 15 minutes and we've already got this much, so I think we're doing pretty good. So the first thing, let's go ahead and rename this back to player platform again, because that's what it is. And then let's add a script, and we're just gonna do GD script. Let's make a new folder for scripts. And then, okay, we accidentally put that inside of levels, so let's move that. Okay, we can't move that yet. Okay, so we'll make a new folder called scripts. We'll put this in there, and we accidentally created it under the levels folder, so let's move it back to the main. And there we go. Now we have our one script and our one level, neatly organized. It's just helpful to keep the organization good from the start. And yeah, so basically what we're trying to do is we now have the player platform, okay? So this is going to move back and forth side to side, probably based on the mouse. We could make it based off of like A and D, but for now let's just do the mouse. So wherever the mouse is, we'll get the mouse's position, and we'll just have the platform be basically on the mouse. And let's see, what else? So the platform is just going to be wherever the mouse is, and objects are just going to fall in, and so the player needs to catch those objects and build as tall of a tower as they can. That's the basic premise of the game. So yeah, let's implement it. Let's hop in this script and see what we can make. So the first thing we need to do is we need to somehow get the mouse's position. And I don't remember how to do that off the top of my head, so of course we'll head to Google and we'll say Godot get mouse position. And we'll see what comes up. Here's our fancy Google search here. As a game developer, you're gonna spend a lot of your time on Google. So what we can do, it looks like there's two ways. Either we could override or just create this input function, and then inside of it, whenever the mouse moves, we'll get an event, and we can do something with that. Or we can just, inside of the process function, we can just say get viewport, get mouse position, and I kind of like that strategy. So let's try doing that, and we'll say variable mouse pause equals get viewport, get mouse position, and then let's just go ahead and print this out, just to make sure it seems like it's working reasonably well. So we have the print statements down here in the bottom bottom center, I guess. And you can see it does seem like we're getting a pretty reasonable numbers. Looks like it goes from 0 up to 1200 or 1150, and then the obviously the y-axis starts at 0 up top and goes down to, what is that, 650 or something like that. So we have the mouse's position. The next step is going to be to actually move this object to that position. So let's try saying position equals mouse pause. I don't know. We'll see if that works. Okay, okay, that was actually really easy. I thought we might have to transform between like the position on the viewport and the position in the world, but it turns out these are one and the same, so we actually already have our platform moving around. Now, I don't think we want the player to be able to change height. So I think we probably just want them to be able to move the paddle horizontally like this, so they don't go crazy whipping it all around like this. So let's make it so that we just set the position.x to mousepause.x. There we go. So now we can't go crazy. We can only move side to side. Now we should also probably clamp it so this thing can't go past the edge. Because if they are playing it in a window like this, we don't want them to be able to do this, what I'm doing right now, because that just doesn't look good. So let's clamp it so they can't go beyond the edges of the viewport. And I think if we get the viewport, let's see if we can kind of fuzzy search and try to find something. Size. There we go. That was pretty easy. Okay, so size. If we can get the size, then we should be able to say, let's see, if mousepause.x is greater than 0 and mousepause.x is less than get viewport.size.x, and then set the position to the mouse position.x. So basically we're saying if it's greater than 0, which is the left side of the screen, and if it's less than the right side of the screen, which we don't know how big it is, so we're just getting the size of the screen, and this should clamp it between these two sides. Okay, now it does clamp it, but it only clamps it, since we're setting it based on the midpoint, it only clamps the midpoint to each side, so we just want to adjust that a little bit. If we get the width of the platform, then we can make sure the left side doesn't go off the left and the right side doesn't go off the right. So let's go ahead and do that. So we just want to say the width is going to be, we can get either the collision shape or the sprite, it doesn't matter. So let's just say variable collision equals get child 1. So that's this is the 0th child. Okay, we want to get the 0th child actually, since we're not getting a sprite. So this is the 0th child, so we're just going to get that child. And then what we're going to say is if position.x minus collision.size.x divided by 2. So this is the width of the object, right? And let's see, is that actually going to work? Because the scale of the object isn't necessarily the same as its width in units, right? So let's do a little check here. If we put this object right about here, and so these two are centered, right? Now if we take our shape and we move it, it's 10 wide. Its scale is 10, right? So theoretically, it's 10 wide of something. We don't know 10 of what. But if we move it 1, 2, 3, 4, 5 units to the left, we can see obviously that doesn't move us halfway over. So we can't just use the scale. We need to get the size of this in pixels, right? Instead of just the size of this in, whatever this is. So let's think about this. We could, it looks like it's basically 10 pixels wide by default, and then when we move it, because then if we move it over, let me see, it looks like half of it, right? So if we move it halfway over, we can get the width of half of it, right? So currently, the width of half of it is 100 pixels. So currently it's 200 pixels wide, but we don't want to hard code in 200 because we might change the size of this. So we know it's 200 pixels wide when the scale is set to 10. So just doing some basic math, 10 divided by 200, right, the scale can be multiplied by 20 to get the actual size of the object in pixels. So if we just multiply whatever the scale is by 20 in the script, then we'll know how wide this object is in pixels. Okay, so let's do collision.scale.x, and then instead of dividing it by 2, right, and multiplying it by 20, right, because multiply by 20 to get the width in pixels, divide by 2, so we are just getting half of the width. We can obviously combine these two and just say times 10. Okay, so just to clarify what we're doing here, we're just getting the width of half of the shape. And that'll allow us to make sure that we stop with half of the shape still on the screen, right? So we don't want the center to go all the way to the left edge. We want the center minus 1/2 to go all the way to the edge, okay? Yeah, so what we're working on right now is we got some ideas from ChatGPT, and the idea we selected by popular vote was that we're going to make a game where things fall from the top of the screen and you catch them. So the idea that ChatGPT gave us was catch the fruit, right? But obviously we need to put our own unique spin on that, okay? So what we came up with is we're going to have a little platform that you can move back and forth, as you guys can see right here. And then what you're going to try to do is you're going to try to stack up the tallest tower. So these objects are going to fall in, and you're going to try to carefully position it so you catch objects and they get stacked in a nice tower for you. That's the game that we're going to try to throw together in just a couple hours that we have tonight. And the reason we're doing a one-shot game is because next week we got something big cooking, okay? I can't tell you what it is, but something big is cooking. I definitely recommend you make next week's stream. If you can make one stream out of the year, you're going to want to make that one. Okay, maybe not. Maybe, obviously, greater things will come later on. But I recommend you make next week's stream because I have a little secret cooking. That's all. Yeah, just a little secret. Okay, so let's just clarify this code a little, right, to help Uncle Bob appreciate us a little more. So we're getting the collision box object, right? Of course, we want to use the same variable name standard as everywhere else. So we can say box width is going to equal collision.scale times 10, because that's what we figured out based on our math. That basically it's 10 pixels wide for each scale here in the inspector. So if the position mousepause.x minus box width is greater than 0 and the mouse position.x plus box width is less than the size of the viewport on the x-axis. This should clamp us on the left and the right. No, my next stream is going to be same time next week. As always, it's the same time. Well, for now, but I try to keep it pretty stationary, right, for certain periods of time, so that it's easier for people to just know when it is. Okay, we have an error. Collision. Okay, because we renamed this to collision box. Obviously, we need to rename it to collision box here as well. Okay, so now that, guys, we're doing 2D because we're doing a game in like 3 hours. So you're not gonna it's gonna be much harder to make a 3D game in like a couple hours than it is to make a 2D game. So, and guys, I don't know if you can see this subtle difference. Maybe zoom in on your web browser, but you can see we're not quite making it to the edge here. It's just like one. It's just like a. Hang on. If we're moving fast, then we skip off the edge of the screen before this thing actually gets to the edge of the screen. So instead of just doing nothing, if the position is past the edge of the screen, we need to set it to the edge of the screen. So let's say, let's separate this into a couple different if statements. Let's say if it's off the screen to the left, right, that's what this is, we'll set position.x to be box width, right, so it's all the way on the left. Else if the position is off the screen to the right, if it's greater than the viewport width, Then we're going to set position.x to be the viewport width, which we should probably make a variable for. Let's make a variable for that. Variable viewport width equals that. Viewport width. Okay, so basically the issue that we're trying to solve here is the mouse can go beyond the viewport, right? Because here, let me just finish this line and then I'll explain it. Because we need the visualization. The mouse can go beyond the viewport, right? If this is the viewport, I can move my mouse off screen to the left. I can move my mouse off screen to the right, right? So we don't want the actual platform to go off screen to the left or to the right. So what we need to do is we need to clamp that. And so now what we're doing in this if statement is we're saying if it's off screen to the left, put the box all the way on the left. And we obviously don't want to set it at position 0 because we need it, that would put the box halfway off screen because the box's position is set based on its center. Okay, so we set it to box width, which technically this actually isn't box width. This is half box width. There we go. That should clarify any issues. Basically, we set the position of the box to be half of the box's width, so it's not all the way on the edge of the screen. It's halfway, right? So it's instead of being the center of the box being at the edge line, the center of the box is half of the box away from the edge line, meaning that the entire box is on screen. And same with going past this edge here. So now even if we go really fast, you can see we're always exactly where the mouse is, except if we go off screen, then this gets locked in place. So there we go, guys. A very quick. Have I ever had a bird with gravy juice? Well, of course. That's every Thanksgiving and sometimes Christmas and whatnot. Turkey and gravy. Turkey and gravy. And I guess chicken too. I don't know. I don't know how often we have chicken with gravy. I guess sometimes. I don't know. Maybe gravy is just a turkey thing. Okay, so we have the platform implemented, guys, and it's pretty solid. There is one issue though, and the issue is the objects that fall in, right, which currently we just have one little object, they don't stick to the platform very well. When the platform goes side to side, they just kind of stay there like a little log. Like, what is that? We need them to stick to the platform. So maybe we can do some shenanigans with the physics system to try to get some friction going, but that's definitely an issue. See if there's anything about friction. Because we want the player, we don't want it to be impossible, right? We want the player to be able to catch these objects and have a decent chance of keeping their tower in place. Currently, if the player moves at all, they're just going to lose their blocks. So ideally, we could have some different blocks with different amounts of friction, and that'd probably make it more fun. So let's take a look through the settings here. We might have to go for a Google. Let's go for a Google. Do I still have this open? This one. Here we go. Okay, so let's see. Godot, rigid body 2D, add friction. Because currently it seems like they're completely frictionless. Rigid body, angular damp. See, I feel like if we do the angular damping, I think that's just going to be it while it's in the air. It's just going to damp it, make it like slow down while it's in the air. Yeah, that doesn't really help us with our particular situation. We need it to have some kind of like material that allows it to, some kind of physics material that allows it to have stick. Oh, hang on, there's a physics material right here. Let's try this. If we add a new physics material, friction of 1, let's see what happens. Not quite. We may also need to add a physics material to the platform, and now if they both have a physics material with a friction of 1, still nothing. Perhaps if we crank up the friction to 10 and we turn on rough, I have no idea. We'll see what works. YouTube really needs to add like a translate feature, like right on there. Hang on, let me see if I can get Apple to translate it for me. Select. Wow, it won't even let me select the text. YouTube doesn't like me selecting the text. Kind of odd. There we go. We managed to get it. Oh, thank you. Awesome. Thank you. Yeah, we're doing our best to hopefully build a little tower game. Yeah, for some reason, guys, if you look in YouTube comments, if someone sends something in a different language, it'll give you like the little translate to English button, but they don't have that in live chat. I don't know why. There's not like a little button that just lets you translate it, so you have to select it and you have to do like a right-click translate or something like that. But I appreciate that. So what we're going to be doing is, what we're trying to do is add some friction, because currently what we're trying to do is have a little platform you can move and the objects can stack in a tower, but that's not going to work very well if the objects are frictionless, which is what it seems like is happening right now. So yeah, let's see if we can find something. This guy's just trying to do rotating friction, which we don't need to. We just need regular friction. Let's take a look. No, we know we need a physics material, and we applied one, but the friction just isn't quite working for us. Interesting. Maybe it's because one of them is a static body. Let's see. I don't know. So we have, let's see if any of these other properties work. Like for example, the bounce. If we set that up to 0.5, let's see if anything happens. Okay, so that part works. So we know the physics material is working because we have a very bouncy platform now. That's kind of fun. But it's not quite. Well, I guess it really never stops. It's not quite what we're looking for, but that's good to know that we could have like very bouncy objects, which could be fun. But the friction is still not working. So let's see what it says here if we hover over it. Values range from 0 to 1. Okay, so let's put it back to 1 then. If true, the physics engine will use the friction of the object marked as rough when two objects collide. If false, it will use the lowest friction of all colliding objects instead. Interesting. So if we turn on rough, if we turn on rough on the platform, then that means it doesn't matter what the other object has as its physics material, because it's always going to use the rough object's physics material. But we're still not getting anything, any friction happening. I just tried lowering the mass just in case it was like maybe too much inertia to actually have the object get dragged, but it doesn't seem like that's the issue. Let's go ahead and see if we have two rigid bodies, both of which have friction. If we go ahead and add a physical material back to both of these, if we have two rigid bodies with friction, do they work together correctly? It's kind of hard to see, but I kind of feel like they are. Because if we tilt it, if we let it tilt, they don't slide off 100% immediately. They kind of have a slow slide. So I'm thinking the issue is because we have one static body and one rigid body. I kind of think that's the issue. Or maybe it's because they're like exactly 100% flat, like 100% horizontal or something like that. I don't know. Very odd. Let's see. Godot, rigid body, friction not working. Do. Alright. Oh, well, this is Unity. It's probably not going to help very much. Unable to remove drag and friction. Rigid body not falling. Rigid body sliding off slopes. That could potentially help. Okay, it mentioned something about a kinematic body, which makes me wonder... Oh, they don't have kinematic bodies anymore. But let's go ahead and try making the player a rigid body again. I know we just switched away from a rigid body, but let's try making the player a rigid body again and just see if anything changes. So I'm going to move both of these over, deactivate this, and of course add our player script to it. Load scripts player platform. So we're going to try player as a rigid body. And we actually need to recenter these on the rigid body and move the rigid body down. Okay, here we go. Let's see what happens. Okay, and we need to change this to just extending. I think we can currently just have it extend node 2D and be workable for all objects, because invalid. Okay, we need to actually delete this static body because scripts still run even when you deactivate objects, which is a little bit annoying. But now it's falling, so let's go ahead and set the gravity scale to 0, and it still gets dragged away. Okay, how can we freeze this? Can we just use like a freeze or something? I believe there's a freeze option. I'm not sure if that's gonna work. Let's try freeze option kinematic. Oh, there we go. That's nice. That's nice. You guys see that? Now, with a rigid body with a freeze option kinematic, we're getting a little bit of friction, but obviously it's only a little bit, so you can still accidentally throw your objects off screen if you aren't careful. So we should be able to tune this if we remove... Well, we don't necessarily want to remove this, but let's see, friction there is set to 1, and now friction here is set to 1. I wonder if that changes. I think it said it just goes with the friction value of the lowest, so it doesn't like multiply them or anything. So if we set this to rough, then it'll take this thing's value, whatever this thing's value is, and ignore the other thing's value. And so you can see here with a friction of 10, get some pretty tight results. So what I'm thinking is we create a couple of different objects, and then we have, maybe some rocks, and rocks have a friction of 10, and we create some wood. Maybe wood has a friction of just 1, and some ice has a friction of nothing, right? So we should be able to... Okay, that's weird. Is the friction just like acts really weirdly? But anyway, with the friction and the bounce, we just use the basically just the built-in properties to get some like different behaviors of the different objects. So it just makes it a little trickier. That's my current game plan. So with that in mind, let's create some basically like object prefabs, right? So we're going to create like objects of a few different types, which basically the different types are just going to be different materials, maybe different shapes too, I don't know. But for now, let's just do a few different materials. And then we also obviously need sprites to show that these are different materials. So let's try to find some sprites. As far as finding free assets for games, for 2D games, Kenny.nl is a great place to go. I don't know if they'll have anything for this, but let's try it. What are we looking for? We're looking for different materials. I'm not seeing many great options. I don't know exactly what to search for, because like we could try searching, because we want like a pack of materials that includes like wood and stone and stuff. So they may not have it here. They have mostly like 2D asset packs like this in the 2D category anyway, and also icon packs. Let's see. Yeah, I'm not seeing any like wood or stone like material type things. Okay, so we're out on that. Another place you can go is Game Fresco has been suggested for us. This is mostly icons, I think. Let's try GameDevMarket.net. And they have, let's see, 2D assets. Free. There we go. Let's take a look. Okay, here we go. This actually looks promising. Yeah, here we go. This could work. Because you see they have these are, I believe, it looks like these are just going to be textures. Just images. Okay, they're at an angle, though. That's kind of weird. I'm not sure if we can work with that. I don't know. I don't think we can work with that. Let's download it and see, but, yeah, no. This is a picture of their file browser, so it looks like they're all at angles, so that's not quite going to work. Let's keep looking. We need, okay, here we go. I like this. This looks, oh, well, now they're just like that. Can we not get any, like, just straight on? People are so strange, you know? We live in a society. Let's keep looking for some standard flat textures. Honestly, we could go to, like, more of a 3D type of place. Because they might have textures that are intended to be used for 3D models, which could be good for us. Like, for example, I know textures.com, I think they have a selection of free stuff. Let's see, free stuff. Yeah, so one thing we could do is we could like take one of these material type ones and apply it to our 2D sprite and just use this texture as like a sprite. So that's an option. We can do that. Let's see how it looks if we do. Because these are just going to be images. I believe these are just going to be images. Hang on, let me log in here for right quick. Yeah, so basically we're just going to take textures that are intended to be used on 3D models and just throw them on our 2D objects, and then it should look pretty good, hopefully. Gotta do some email activation. Email activation. That didn't make any sense. Yep, just a fancy little login process. Nothing to see here. Okay. And we should be good to download. So let's go ahead and take a look in our downloads folder where we just downloaded our new texture, and yeah, they're trying to throw us some shady file. Well, not shady, but they're trying to throw us materials that have already been compiled and not the actual source files. Oh, but it looks like there's a download option for the source files as well. There we go. That's what we're looking for. I think that'll work pretty well for like a wood texture for our wood objects that we're throwing in. So that's wood. What else do we need? I'm thinking a wood, maybe a stone. Any of these look like good stone. Maybe this one. They have foam. Interesting. Yeah, let's do this stone. This looks pretty good, I think. We can just scroll down and select the main albedo image. Okay, so we got stone, we've got wood. What else? There's some foam, but I don't know if squishiness might be off the table for us for now, because that's a little bit more difficult. Okay, not a whole lot of options here, but we could do like a tile one like this. This one right here is a nice tile one. Pretty something like that could be a good one to have like kind of a smooth option. Okay, so we got wood, which is going to be like, we got stone, which is going to have a lot of friction, wood, which is going to have a little bit of friction, and then the tile is going to have like no friction. And then the only other thing we might need is we might need a something for the players, paddle thing that they're moving around. So as far as that goes, this could be a cool option. Let's go ahead and download this. It's like a solar panel. That looks cool. Also, we have a tired battery, so let's go ahead and charge that. This dust overlay is kind of giving me an idea that together with the solar panel texture, maybe we could do kind of a space theme in the background. Some stars, a solar panel thing, and then objects just fall in because it's outer space, whatever. Apparently, there's wood and stone in outer space, blocks of that. That's the game idea, anyway. That's what I'm thinking. So let's import these textures. Go and throw in a new folder, textures. Okie dokie. And then let's go ahead and grab our files from the downloads folder. Maybe rename them. Tile, wood, solar panel, and rock. And then we'll go ahead and throw these in the textures folder. If we can. Please import. Okay, it doesn't. I guess it doesn't like them. Let's try forcing it. If we search up our project, which is called Catching Fruit, then we can just open up the textures folder and throw these in the. Oh, it looks like it did import. It was just taking a second. All right, let's see if we can. Can we refresh this? It is not refreshing. We do have all of our textures imported, but it's not refreshing, so we might have to restart it or something. Because I don't think there's a refresh thing here, unless this refreshes it, which it does not. Okay, let's go ahead and just quit Godot and relaunch it, just so we can get those textures showing up in the editor, because for some reason they aren't quite. But if we go ahead and... that's kind of odd. Maybe it doesn't like .tiff files. I don't know. Let's search it up. Does Godot support .tiff? Okay, it looks like it doesn't because someone's asking for them to add support, so we're just going to need to just convert these. And let's just go ahead and select all of them and convert them to, I guess, JPGs. It should be supported by Godot. Convert. Okay, so we convert those to JPGs, then they should all be supported by Godot. We should be able to import them and actually see them. Let's open up all of our relevant folders in the file browser, and here we go. Drag them all in. Boom. Beautiful. So that was why they weren't showing up, because the file format wasn't supported. But now, if we go ahead and grab, let's say, object, we'll rename it to wood, and then let's go ahead and throw the wood texture on this sprite and see how it looks. Okay, it has gone mega gigantic. We may have to make some small adjustments to the situation here. Yeah, just set it to a 1:1 scale and see how it does for now. Okay, still much too large, because remember we need it to be the collision shape, so if we reorder these, we can get the collision shape in front, and that'll let us get an idea of how to do this. Let's set this to 0.5. Okay, that's close. That's close. Let's just edit the final touches with these handles. Okay, now we may not want them all to just be rectangles like this. And also I feel like the texture is not great. It's just too small, really. Yeah, we don't need the whole texture to be shown, which I guess it isn't, but we'd like it to be blown up a little bit more. So let's see if we can do something about that. We turn on region. Not sure if that's going to actually work, but let's try it. If we actually just make it a square, then we could just take a nice 2x2 of these I feel like that could be a good look. Okay, and then and then we just adjust this to more square size. Okay, now it's stretching too, which I don't like. So we definitely need to make sure that it doesn't stretch. Let's see. I know the collision isn't set up correctly, but let's see what size this is. Okay, that's huge. That's still much too big. Let's maybe make it like a quarter, and then it'll just be like a little wood block. There you go. A little wood block. I think that's good. And then we just want to reset its position so that we can get the collision to be the same size as well. There we go. What do you guys think? You think that looks good? Nice little wood block for us. And then we'll just do a similar thing with the other objects. Okay, so the wood is going to be like a little square. Ooh, we didn't quite get this right. Let's see. Move this collision shape. Okay, I think it's right. Okay, wood square. There we go. Wood square. The wood square drops in, even rolls a little, but somehow it falls through. So let's take a look at this thing's collision. Okay, there we go. So we messed up the collision on our main player platform thing. So let's fix that. And then we can go ahead and apply. I think we do want the player platform to actually be like more of a rectangle like this. But let's also go ahead and apply the solar panel texture is going to be our player texture. And of course we need to shrink this down. And we can select a region, edit region. And for this, let's have actually if the corners were like this, I feel like that'd be nice. If they were like on these white edges, and we can have like, yeah, some nice little, that way it'll have like nice angular corners. I think that'll look good. So let's just try to, whoa, scroll speed is like super high in here. Okay, let's just try to line these up halfway between, so it's nice and even halfway between. And this should allow our our player's paddle thing to have this nice solar panel texture. Okay, there we go. Once again, with the stretching, let's go ahead and reset this back down to 1:1. And zoom in on it a little bit, and then see if we put the collision shape in front again, we should be able to modify this guy's size to, let's try to get him down to a decent size. If you hold shift, then you can resize without damaging the aspect ratio. So you can see if I don't hold shift, then this, but if I do, then this. So we can hold shift to have that. That's very helpful. Okay, so this is not quite wide enough. Let's see if we can edit the region to get a couple more squares. Yeah, let's do all five. I wonder if we actually drag it off, it actually does mess it up. So let's just go ahead and drag it carefully to the edge. And there we go. That's actually perfect. It's kind of nice. Yeah, it actually perfectly lines up with all 5 of those. It's perfect. Beautiful. Okay, I actually don't love the way it looks, but it'll have to do for now. Also, the friction is behaving very weirdly. Maybe the fact that we set it to 10 is messing it up. Let's again turn off rough as well, because we don't want to override the collision of all of these different objects. We want them each to have their own. So if we turn off rough, now the wood will have its own friction, which is 1, and it's not quite working. It's actually frozen. Okay, so if we turn off can sleep, I'm a little yeah, I think maybe the wood fell asleep, because basically if it's just sitting here like this, eventually the wood thing comes to a stop and it's like, okay, well, maybe I shouldn't do calculations anymore. So if we turn off can sleep on the wood, now it won't fall asleep like that. Okay, we've got the wood, which the collision shape got messed up again. Is there a link between these? Hang on. I think there's a link between these. I don't know why. I don't know how. But I think there's some kind of a link between these two collision shapes, because if I do this, it does that. Not good. I don't know why, but let's just go ahead and add a new collision shape 2D instead of that, because somehow there was a weird link between those two. I don't know why, but if we add a new collision shape instead of that, rectangle, of course, resize it up. Nope. Resize the collision shape. And there we go. Perfect. It's a little thin on the sides, but it lines up pretty well on the top and bottom, which is what we care a little bit more about, because that's probably going to come into play a little more. Like, there, it's landing obviously on the top and bottom. I know, I guess it flips around, but still. At least it's lined up correctly on one, on the top and bottom, so that's not bad. Okay, so we have a wood square. Let's go ahead and create a stone shape as well. I don't know what shape it should be exactly, but yeah, let's also see if these are linked, because I duplicated them. I wonder if that's what happened. Yeah, so if you duplicate it, it's linked. Very odd. But it's only the collision shapes that seem to be having this issue where they're linked. Just the collision shapes. The other ones don't link if they get duplicated. I don't know what's up with that, but we'll just create a separate collision shape. Also, let's change this to stone, or technically we called it rock. And then let's see what kind of a shape we can cook up here. Okay, so this is our rock texture. What kind of a shape should we do here? What about like a tall skinny? Does that seem nice? A tall skinny? I just want there to be some amount of variation here between the shapes. So yeah, wood is going to be a perfect square. A stone is going to be tall skinny, and then maybe the smooth tile one could be like a short, like low thin one. But yeah, okay, so rock's going to be a tall skinny, so it doesn't really matter what we select, but we'll select that. And then we'll go ahead and add a collision shape 2D, of course, set it to rectangle, and then position it around this. Here we go. Okay, I think that's pretty nice. Let's see if we can catch both. Okay, we couldn't because of the way they're positioned, but not bad. Also, we want to increase the stone's friction. So, physics material, let's go ahead and set this to 2. Let me make sure these physics materials, the physics materials are linked too. Dang it. Okay, so let's reset this. New physics material, there we go. Physics materials are unlinked now. Make sure they're all unlinked. Okay, so the stone will have a double friction, and the wood will just have a regular single friction. So as you can see, the stone has a lot of friction. But it can still fall off, so I think that's reasonable for now. And then the last thing we're going to do is we're going to create the tile. And the tile one is going to have basically no friction. And we'll also, of course, have to figure out a shape for it. So let's drag in the tile and see what kind of a shape would look nice with it. And yeah, I just want to make them each slightly different shape than each other, just for visual interest. Yeah, why don't we do like maybe a 2x3? Two by three. That's what I'm thinking. 2x3. Just on the outside, just on the outside, just on the outside. Okay, I think that should work. Just a nice 2x3. Let me just move this off so it's just more easy to see what's going on. Okay, and then of course we want the collision shape to actually line up. Is Godot 3D easier than 2D? No, in general, 2D is basically always easier than 3D. Because it just, I mean, it's just, you know, less to worry about. And everything in 3D just takes so much more processing power, right? Because the rendering, first of all, you have to, instead of just rendering, you know, these pixels from this image just get put on the screen. Easy peasy, right? If you're in 3D, you can't just take pixels from an image and render them to the screen. What you have to do is you have models, and those models you have to calculate. There's a whole bunch of triangles. The models are made up of triangles usually, and so then you have to calculate each triangle, and if the camera can see it, you show it, and if not, you don't. And just everything is just so much more performance intensive on 3D. So 3D is basically always just going to be harder. Okay, so now for our tile, the last thing we want to do is we want to make its friction maybe like 0.1, so it's very, very slippy. Yeah, there we go. So if we slide this way, you can see it's very slippy. Our stone does a pretty good job staying on. Okay, we lost it, but the tile is very slippy. Okay, so that's the core of our game, guys. It's taken us about an hour to already prototype this entire thing. A player platform that moves around and 3 objects. Okay, that's how far we've gotten in just 1 hour. So if somebody tells you you can't make a game, just pick something simple, something like this, and just make a game. Easy peasy. Okay, so I think what we want to do is, now that we have these 3 objects as base, we have what they're going to be like, we probably want to create some kind of a spawner that will just sit here at the top and just drop objects down, and then we'll try to stack them on our platform. And then we'll have our core game loop basically locked in. So we first need to turn these basically into like prefabs. So let's create another folder. I'll call it prefabs. And we just want to make these able to be actually spawned in. So I'm just going to throw them in the prefabs folder. Okay, it doesn't like that. I think we have to create, let's see, what do we have to do? Right click on them and do save branch as scene. There we go. And then we select our prefabs folder, and we'll call each of them the blocks. So we'll call this one wood block. And now we have our wood block prefab. And then we'll do the same thing here. Right click, save branch as scene, stone block. And then right here, save branch as scene, tile block. So we're gonna have our blocks, and now you can see basically it just collapsed them all from multiple nodes nested together into one. But if we double click on one, okay, if we click this button, then it'll show us the scene, which is this file here. And then obviously we can edit that file. But now if we delete them from the level, they're still here in the file structure, so we can still spawn them in with a new script. And yeah, let's go ahead and make that script. Also, let's add in a camera, because we don't currently have a camera. And basically what Godot does is just creates a default camera with the top left corner at the origin, and then just spreads it out. But if you want to have your own camera to control some stuff, you can just create a camera. And there we go. Now our camera is centered on the origin. It doesn't really matter, but if our camera is centered on the origin, then it'll just make it a little bit nicer, I think. Okay, and then we can set our player to 0, 0, except a little bit lower on the y-axis probably. So 0 on the x, and then it's going to be maybe like 200 down on the y. There we go. And we're having a little bit of an offset issue here, because, well, these don't actually have any transform, so that's a little odd. Why are we having that? Oh, so the reason that our positioning was working before is because the camera was actually down here. That's the reason why it was working, because conveniently the 0 on X and 0 on Y were both up here, just the same as they are with the viewport. So that's the reason that was working. So I guess to preserve our script working super easily and looking super nice and minimal, we're just gonna do this and just put the camera back down there, and then boom, it's working again. It's not working. You know what? We don't need a custom camera. We don't need a custom camera. For something like this, it's better to be simple. And now we've somehow broken it. Hang on. We have somehow broken it. Okay, let's see. We still got the collision and the sprite in. So let's take a look at what we've done that has messed us up. Somehow we're no longer actually stopping, you know, at the edge, obviously. If mouse position minus half box width is less than 0, position.x equals half box width, sure. Yeah, so we haven't changed the script, but it is now not working quite correctly. Yeah, that's quite odd. Collision box does scale at x times 10. Yeah. We didn't actually change anything here, so that's very odd that it would break like that. Let me see. What could we have changed? So at some point in our journey where we did various things like adding the other boxes, we have somehow broken the player movement here. So let's go ahead and try to fix this. And usually if you're having trouble fixing something, what you want to do is print out lots of stuff. So what we're going to do is we're going to print out which of these cases we're in. So here we're going to print out off left side, because we should be off the left side of the screen. Here we're going to print out off right side. And here, well, for now, let's just print nothing. All right, so if we're off the left side, we start printing like crazy. Let me just sweep that. Okay, well, let me do a little reposition here so that this is over the center here. Okay, and let's see when it prints off left side. Okay, it seems to print off left side when the mouse position is less than 0. It's almost as if half box width isn't there. So let's see what happens if we remove half box width and see if anything different happens. Nothing different happens. Let's try printing half box width then. Oh, I see. We switched the order of the collision in the sprite. So now it's checking the size of the sprite instead of the size of the collision box. So yeah, that was a little bit of a fragile way to set that up. Maybe we should have, okay, maybe I was wrong. Oh, and then we obviously need to add this back. So basically what happened, guys, is I said get the 0th child, and so I was messing around in the inspector doing whatever, and I switched the collision shape to in front of the sprite, and it started looking at the sprite size instead of the collision shape size, which is why it broke. But now, but now if we put it back to the way it was, which I think it isn't, which is mouse position.x minus half box width is greater than 0. So if we put it back to the way it was before I messed it up with our testing, we get the correct solution back. So now we're checking if the left side of the box, which is the position.x of the box, which is the center, minus half of the box's width, right? So the left side is greater than 0, and the right side is less than the viewport width. And the right side, of course, is just the position.x plus half the box width. So box is fixed again. Let's go ahead and add another script to actually spawn in objects and drop them down. And we might as well add it on the scene root, because why not? Of course, we're going to want this to be in the scripts folder, and we'll call this spawnblocks.gd. And we'll create it. Okay, so what we want to do here is every certain interval, we want to spawn a block, right? And even if that interval is decreasing whatever, it's still going to be every certain interval. So for now, let's just do a static interval. And we're going to go ahead and use the add export to say, put this in the inspector. And we're going to say add export variable interval equals 1. And we should also specify this as a float. equals 1. Okay, forgot an equal sign there. Okay, so there we go. Now we have the interval in the inspector, right? We can set that however we want. And then we need to add in probably an array of prefabs, right? So if we make a little array and then just pick a random one from that array, then we'll be able to add as many blocks as we want to the array if we add more blocks later. And it'll just pick a random one from the array. So I think we can make this a public array by saying at export variable block types, and then we'll say this is an array of I guess we want it to be an array of strings, because these are probably just going to be the locations of these objects. So for example, the first one would be res : / prefabs / stone block dot tscene. Okay, so this is just going to be the locations of the blocks, and I'll pre-fill it for now, but obviously if we add more later, then we'll just be able to add those onto the end as well. So stone, currently we have stone, tile, and wood, so I'll just put those directly in the script. But since we exported this, if we click on it in the inspector, you can see we could just add another element and then type in wherever it actually is. So that's pretty handy. Okay, so we've got our blocks, and now what we want to do, we should also have the current time. So let's go ahead and create, this doesn't need to be public, a variable called time, which is also going to be a float, and it's going to start out at 0. So every time we have a new frame, right, this is called every frame, as it says right here, we're going to add the time since the previous frame. So this time variable is always going to have the time since the game started, right? Because on the first frame, it'll be however long it took to render that frame. The second frame, we're going to add the last frame to it as well. So the time is how long the game's been going. We could do that, or we could actually make it less variables by saying time since spawned. And we're going to have time since spawned plus equals delta. And then we'll say if time since spawned is greater than interval, time since spawned equals 0. Okay, and then just to show this is working, we're going to go ahead and print out spawn, because we would be spawning an object here. So basically what this is going to do is it's going to increase this by delta. So every frame it's going to increase this by however long it's been since the last frame. So if we're running 60 frames per second, it's going to be 1/60th of a second every time. And then 60 frames later, this is going to be greater than interval, or I guess we should say greater than equal to. And then once it passes interval, or is equal to interval, we'll print spawn and we'll set it back down to 0. So it'll take a whole nother 1 second, or however long this is, before we print spawn again. Let's see if it works. Spawn, 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 spawn. And there we go. We can see down here it's printing it once every second. So there we go. We have an interval system set up, and it's pretty simple and clean. And now what we want to do is actually spawn one of these guys. So to spawn one of those guys, what we have to say is we have to do, it's kind of a two-parter. We have to go in and say variable block resource equals load, and then let's just for now just say block types 0. And you could see, by the way, when we typed in load, it was trying to get us to put in one of these strings, just like this, which is the string that we have up here. So we'll just pass in the string, and it'll go and get that resource and load it up into the block resource. But that's not actually an object yet. It's just saying, it's just all of the information from the resource. It's basically just gone and gotten that resource and loaded it into memory or something like that. I don't know exactly. I haven't looked into it that much. But it hasn't turned the resource into an object that we can put in the scene. So the next thing we have to do is we have to say block equals block resource dot instantiate. Okay, and now this is an actual object that we can put in the scene. But it isn't in the scene yet. So we have to do step 3, which is add child block. So first we go and get the resource and load it into memory, I think. Then we go ahead and turn that, say, hey, look at the resource and make an object out of it because this is a template for an object. So go ahead and make an object after that template, based on that template, And then the last thing we do is we say, okay, actually put it in the scene. And at that point, it will start rendering it and running its rigid body functions, etc. So if we do this, since we're saying block type 0, it should just go ahead and every second keep plopping us in with a stone block. So let's see if that works. Stone block, stone block, stone block, stone block. Nice. Now, of course, it's still spawning it at the exact same position, and it's spawning the exact same block every single time. So we just need to add a little bit of randomness to this, and it should look pretty nice. So what we're going to do is, I don't remember how to generate a random number in Godot, so we're going to say Godot generate random number. And guys, this is what I'm saying. You don't need to have experience with making games to make a game in Godot or another engine. You can just Google it. I've been making games for 7 years, almost 8 years now. I still Google things a lot. Okay, so in Godot, it looks like to generate a random number. Is this the shortest way to do it? This feels a little long. Let's see if there's anything else. Okay, I guess we do have to do it that way. So you have to create a random number generator, and then you can give it a range, and it'll create a number within that range. And you can do a random integer in range, which is what we're going to want, because we want an integer to fit in the array. So at the we're going to go ahead and say random number generator at the top. And then inside of our ready function, which happens just once at the start of the game, we're going to say random number generator equals this. Now, I don't like this. This seems a little short and a little unclear what it is, in case we have someone less experienced looking at this code. So let's just go ahead and spell it out. Generator, if we can spell generator, that is. Let's just go ahead and spell it out, because we have, guys, we're not going to run into space issues on this program. Like, it's not going to, it doesn't matter. It doesn't matter. This program, the lines are very short. We're not gonna be sticking off the end with these long names. We might as well make it a nice long name so everyone understands what it is. So we have a random number generator, and when we want to generate a random number, let's say block type, right? Because this is the and this is going to be an int that says, hey, what type? We can just say random number generator dot, what was it, rand I range or something like that. Rand I underscore range. There we go. A random integer in range, and then of course we can pass in our integers, which is going to be 0 and block types dot size. There we go. So the size of the array and 0, and let's just check right quick and see if this is inclusive. Let's see, rand I range. It is inclusive, so we need to subtract 1 off of this, because if we didn't subtract 1, the size of this array is 1, 2, 3. But this is index 0, this is index 1, and this is index 2. So if we didn't chop this off by 1, then we could generate a 3, in which case we would be asking for index 3, which 0, 1, 2, no index 3, we get an error. So we'll handle that by just chopping 1 off. It'll be a number between 0 and 2, because right now this is 3, and we'll get one of these strings, and we'll throw it into our load function right here. There we go. So now we're going to generate a random block type. Let's go ahead and test that. Okay, we're getting a couple of wood. Now we got a tile, very slippery. Now we got a stone, tile, 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 wood, tile, tile, wood. Okay, so perfect, guys. It's generating them all. It's generating them randomly. Pretty nice. Now we need to make it randomize the position so that it randomly generates them somewhere in the frame, but the player actually has to do the work of moving their paddle and collecting one. So, let's see. This is the, okay. So after we add the child, we're going to want to set block.position to something. And once again, we're going to use our random number generator. But the question is, what are the position options? And the position options should probably be everywhere from, since the left side of our scene is 0 on the X, we can just say from 0 all the way to whatever the viewport width is. And we can just generate something somewhere along this. And then that's it. So let's go into our script, and we can say, let's go ahead and get the viewport width the exact same way we did in the player platform thing, get viewport.size.x. And here we go. Viewport width equals get viewport.size.x. Block.position.x is going to equal random number generator dot random float in range, right? So randf underscore range. And then this could be anywhere from 0 to the viewport width. Okay, so now we're going to say, hey, once you spawn in the block, put it horizontally somewhere between the left and right sides of the screen. And I just want to wait until we get like one that's pretty much on the right, because I want to make sure that it is actually working and going all the way over to the right. And guys, you can see it's plenty random, right? We can get one all the way over on this side, and then back in the middle, and then all the way on that side. So slight issue here, right? Sometimes we have them sticking off, which doesn't look good. So what we want to do is we want to just pad the edges a little bit. All right, and just to be nice, instead of just padding it by the minimum amount, let's pad it by just a decent amount, right? We'll put in a little bit of extra padding just to make sure, just to make absolutely sure that, not just to make absolutely sure, but just to make it a little easier for the player. So this block is, let's go ahead and take a look. If you remember, we actually don't need that in the scene. If we open up our tile, right, which is the widest block, this block, the collision shape is scale of 1. Oh, because we added the collision. Let's just manually do it, right? So if we move this over to the edge, and then we look in the bottom left, it shows us how far we moved it, 48 pixels. So if half of this is 48 pixels, the entire thing is 96 pixels. So we could just pad the edges by 48 pixels to make sure that these stay 100% on, but to be nice to the player, we'll pad it by a little bit extra, and we'll say viewport width minus padding. Let's make a variable for padding, right? So we'll start at 0 plus padding, which is just padding. And then our padding can be whatever we want it to be, but let's call it side padding, actually. And we'll pad the sides by, let's say, 100, okay? So instead of having there be able to be a tile block exactly on the edge, if we padded it by 48, we're going to say, okay, well, let's move it in a little bit. So the objects are going to be like 50 in from the side at the maximum, right? I think that's just a little bit nicer to the player to make sure there's nothing sliding exactly along the edge. I also think it'll look better. But yeah, so we just are going to generate them in the range of 0 plus side padding to viewport width minus side padding. And that should, wow, I really yeeted that one. Yeah, I'd say it's very hard with these tile ones. They're very, they're very slippery, I have to say. And it's become clear that I'm not very good at this game. But I think it's a little bit too hard, right? Because if we try to drag this along, they just don't. It's too, you're never going to be able to move all the way over in time to get something, and then also with these being that slippery. You wouldn't prefer I don't know what you mean. I wouldn't prefer a manual solution. You want us to automatically detect like the widest object? I don't know. I don't think the overhead is worth it. Because currently we just have like 3 objects. Let's say we add a couple more, that's 5 objects. Loading up an example of each of those 5 objects and then checking them in the start function, I think that's too much work. I think it's not worth it. And if you take this game to an extreme, you know, where we make 100 objects, it's just a lot of work for this to do for something that I think it's more reasonable to ask the human to do the grunt work. Yeah, I don't know. It could go either way. It kind of depends on the game, but for something quick like this, I think it's okay to ask the human to do the grunt work. I don't know. Okay, the other thing is an object doesn't spawn immediately when we start, so we're just kind of sitting there for 1 second. So what we can do to counteract this is just set time since spawned to minus 999, and that should make sure that we immediately spawn one. But it looks like it. Oh, wrong way. We're going to set it to positive 999, and that will make it immediately spawn something. And with the way the code is set up, we could obviously just set this to 1. Actually, let's make this a little cleaner. In ready, we'll set time since spawned to be equal to interval. Okay, so now no matter what, whatever's going on up here, in the ready function, it'll set time since spawned to interval, and that'll make sure that we immediately spawn one as soon as start happens. So yeah, that's nice and easy. Okay, so I do think it's a little bit too hard because the friction just doesn't quite work well enough. Like, you have to move it really slowly if you actually want to get something done, and the fact that the objects just come in so quickly and so randomly means you're never actually going to be able to collect these, because obviously, it's pretty easy to collect that one or that one, but you immediately lose the one that you already had. So I think it's a little bit too hard. What can we do to fix this? Well, there's a couple options. One, we could warn the player when an object is coming in, like where it's going to come in. So if we made it so objects only come in every 3 seconds, and then before an object 1 second before an object comes in, we'd say, oh, it's going to be right here with like a beam of light or something. That could help. Also, the I don't know, the built-in friction just I don't love it. It just doesn't seem like it's working super well. And if we were to set the friction up to super high, like if we turn on rough, it'll override the friction, set the friction to 100. It just kind of has some weird results like this. Like that. Like what? So obviously the friction isn't meant to be set super high, but if we leave it at the variables it is already at, it doesn't seem to work super well. I don't know. I am noticing they stick a little bit better to each other, and I wonder if it's because we're moving this thing with code. And so if we move this thing with code, it's teleporting, which makes it harder for them to handle it. If instead of teleporting, we moved this thing with rigid body forces, then maybe that would help. But we are currently frozen. So the question is, if there's a way to freeze the thing on one axis, right, so it can't get any lower, and then we move it using rigid body forces instead of teleporting, then that could be pretty nice. So I think the teleporting might be the problem. Okay, let's see if there's a way to Godot freeze rigid body on one axis. That's Unity. I said Godot, but it likes Unity. Hang on. Search for axis. Aha. We have some booleans here. Set axis lock. Okay, this is technically on rigid body and not on rigid body 2D, but hopefully rigid body 2D has something similar, because it looks like we have a set axis lock function, and then we pass in, one of these constants, and then that seems like a pretty solid plan. So let's try in the ready function for the player. Let's try set axis lock. Let's say if we set this to just temporarily say extend, well, we need to actually set it to rigid body 2D because otherwise it won't know what's going on. Set axis, Okay. Set axis lock doesn't quite seem to be working. Let's try Godot rigid body 2D docs. Try to open up the rigid body 2D and let's see if we can find something like this. No, does it not have an axis lock option? Oh, okay, it looks like it doesn't. So they have... let's search for lock. Wow, yeah, so it looks like... I mean, they have a lock rotation, but we don't care about that too much. We really just want to lock it on the y-axis and not on the x, but it doesn't look like they actually have support for that. So it's kind of rough. Okay, so another option, this is kind of a potentially kind of a tacky solution, but another thing I did think of is we could have it so that the objects that hit the platform always stick to the platform, and then the objects on top of them can fall. But then if an object was sticking off the platform and it got permanently locked to the platform, that wouldn't look great. So like one solution that I thought of is, okay, we make it so that brown cube, as soon as it touches the platform, it just instantly sticks to it. Or maybe not as soon as it does, but as soon as it comes to a rest. And that would prevent this sliding offing. But the top objects could still slide. But the issue is if an object comes to a rest like that on the edge, probably shouldn't be permanently locked. So I do think we need to use their physics system for this, unless we want to write our own, which we probably don't. But yeah, the question is how can we remove the teleportation stuff from our code? And yeah, let's try removing this position stuff. And instead, let's see. We want to, I guess instead of doing this, we want to say, we want to add, if the mouse is to the left of the box, we want to add a force to the left. And if the mouse is to the right, we want to add a force to the right. So let's go ahead and start by doing that. If mouse pos.x is less than position, add force, not constant force. I think just force. Apply force. There we go. And then I don't know what force we're going to want to apply, so let's just put in a random value and see what happens. Of course, we want to do apply central force. And that'll just... Okay, and then we need to have this be a vector 2. So apply central force, vector 2, 10 on the x, obviously 0 on the y. Okay, we need to check, obviously, if the position.x is less than the position.x. Okay, 10 doesn't seem to be enough, so let's try throwing in something quite large, like 10,000. Nothing. Throw some more zeros on there, see what happens. Okay, let's add a print statement here. Adding force. Okay, so it's not, okay, it is running, but it's not doing anything because we have the object frozen, obviously. Okay. Fair. So instead of applying a force, if we can actually set its velocity, set axis velocity. I'm not sure if this will work, but if it does, then we could actually set its velocity, and that would allow us to set its velocity on the y-axis to 0, so that it would never get off of the y-axis. And then, of course, we'll turn off freezing. See what happens. We also need to turn off rotation, because obviously it's doing that. So lock well, that looks like it's a Boolean, I guess. Okay, it's still got pushed down. It's still getting pushed down by the weight. So that's interesting. Think. How can we freeze it on? We might have to do teleportation as far as the position goes. So if we say, let's see, variable height, and then in ready we say height equals position.y, and then in every frame we just say position.y equals height. So basically we're just storing the height that is at the start of the game and then forcing it to always be at that height. Let's see if we can get a block dropped on us to see if it has any weird results. Give me a block. Guys, can we get a block over here on this side? That's crazy. Okay, they're clipping through it, it looked like. Yeah, that one's solidly clipped through it. Interesting. Okay, so teleporting height is also not going to work. But currently, obviously, we're still having the problem where we don't have any gravity, but we still get pushed down. Kind of not great. Okay, so however, if we add else if statements to cover every situation, so if it's less than the position.x, we actually need to make this be like a minus, let's say 100. And if it's mouse pos.x is greater than position.x, then we want to add a positive 100, and otherwise we want to set the velocity to zeros. Okay, so if we cover every case, then we shouldn't have any issues, because we should be making sure we never are allowing a downward force. However, it looks like we can still, okay, we are getting kind of the desired behavior, but it's going down. It's going down. Yeah, we really need a function that just like allows us to lock the height in. Ooh, I wonder if we set the mass something super high, if that would make it so that the things can't actually knock us down. Yeah, there we go. Now we're cooking. Okay, so if the mass is low, then when something hits us, it can get a quick push before we stop the velocity real quick. But if the mass is super high, they're going to have such a small effect that it shouldn't ever be visible. Nice. Okay, and they are locking on much better now. The friction seems to be acting much more realistic now, because we're not teleporting anymore. You can see like we get the little bit of a shove, but like it's so much, yeah. That feels a lot better, guys. I don't know if you guys can tell because you're just watching, but it feels a lot better now. Obviously the movement is terrible, so let's actually do something about that. First we probably need to add a variable speed. And of course this is going to be a float, and for now let's set it to 1,000, and this is going to be -1 times speed, and this is going to be just speed. And we probably need to add some kind of a buffer so it's not always moving, right? So if our so you can see it's like flipping back and forth like this because we're on the line, and so it moves to the right and then it needs to move to the left, and it just is flip-flopping back and forth. So I think if our mouse is on the paddle, it should probably not move. But if our mouse is more to the right of the paddle, then it should move to catch up. And same with to the left. So we're going to need our half box width again. If mouse position is less than position.x minus half box width, or if it's greater than position.x plus half box width, then we're allowed to move. So now if our mouse is over the paddle, nothing happens. But if we move it to the left or to the right, then we get some movement. We're way too fast now. So let's go ahead and set this in the inspector. We can set this down to a nice 200. I don't know. It feels a little... Okay, first of all, the velocity doesn't seem to go away. If it's less than position minus outbox, and if it's greater than position plus outbox. Yeah, I don't know. It seems like the velocity isn't quite going away. I'm not sure why. So if we hold this to the right, then it should stop when it gets here, but it doesn't. right? If my mouse is over it, it should be halted in place, but it doesn't seem to be. Let's check the documentation for this set axis velocity. Sets the body's velocity on the given axis. The velocity in the given vector axis will be set as the given vector length. What the heck? Maybe we're using the wrong function here, guys. If we can just set the velocity itself, which is what we want to do. Velocity. Angular velocity, linear velocity. Yeah, what if we just set the linear velocity variable? Let's try that. Linear velocity equals, and then this. See, okay, it does allow us to do that. So then we're gonna do the same thing here and here, except of course, we're going to set it to the correct values. All right, let's see if this works a little better. I think we were using the wrong function before. There we go, much nicer. Now, this feels a little slow. I definitely think it should be faster. But I think we also should multiply based on the distance from the paddle, right? So if we moved far and fast, then if I move, like if I whip my mouse all the way out here, it should move fast. If I just move it a little bit, it should move slow. Okay, so it doesn't jolt like that. So let's add that. So, and we also need to add clamping, so it stops at the edge of the window. But definitely some good progress here. It's feeling much better. So to get the distance from the mouse to the position.x, variable distance equals mouse position minus position.x. This will give us a vector that's pointing from position.x to mousepause.x, and then we can just say dot length or something like that. Mousepause.length. Yeah, perfect. Mousepause.length, and then we need to take the absolute value of that, but we could also just do it squared, and we'll get a non-existent function in base float. We actually don't need to do any stuff because the only difference that we're caring about is on the x-axis. So we can just subtract these two, we can get the absolute value, and we can roll with that. So for getting the absolute value, let's see, Godot math library. Yeah, it's capital math. Math.abs. Mouse position.x minus position.x. Math not declared in the current scope. Okay, that's a little weird. It should be. Godot get absolute value. Oh, is it just built-in abs? Okay, perfect. So we have the distance. Distance to mouse. And we're going to multiply this by the distance to the mouse. So, and we're going to need to decrease our speed probably drastically to make up for this. Yeah, you can see we're just like shooting off screen or something. So let's just go ahead and set it to 10. But the idea is that if I move my mouse away fast, then it'll, catch up fast. And if I move my mouse slow, then it'll move slow. And of course, you kind of want to move it slow because otherwise it's going to get out of control. Now there's something weird going on where it's like snapping. But that's because I set it so that you only can move if you're off the edge of the platform, right? So let's try removing that and seeing what happens. Because theoretically now, if we're super close to the position, then we won't move much. Yeah, so we've stopped it from being like out of control, right? So if I want to move slowly, then I just stay nice and slow. I was able to knock that over, so now it balances pretty well. Let's get that. Oh no, I think we're going to lose it. Oh man, that's rough. Okay, let's try to get another one. Ah, they're just coming in too hard. There we go. Ooh, that's looking nice. Maybe we should just wait for something to fall in. No. Okay, but I feel like, guys, it's working pretty nicely. Pretty nicely. For a game that we just threw together in like an hour and a half. Pretty solid concept. Pretty good functionality. Clearly not very good at it, but and we also still need to fix clamping. So let's go ahead and fix clamping, because currently we can just go off the edge. So the question is, now that we're using forces to move the paddle, which does feel a lot better, now that we're using that, you know, there's just like a little bit of lag, and it just feels so much better. It's like kind of springy. Definitely feels a lot better than when you're just teleporting it. But now that we're using that, how do we make sure that it doesn't go off the edge? That is a tricky one. So we probably need to check if the way it's currently moving, right? So if the position of it, and then we add the force, right? So let's say it's moving to the right 10, and if that moving to the right 10 on the next frame is going to move to the right 10, right? If that takes it off screen, then we stop it and we just make it move only to the edge of the screen. But before we make it only move to the edge of the screen, let's just currently say, if it's going to go off screen next frame, stop. Okay? So how do we check if it's going to go off screen next frame? Well, we say if position.x plus linear velocity is less than 0, linear velocity equals vector 2, 0, 0. And we also need to say just linear velocity.x. Now, I'm not sure if we need to multiply linear velocity.x by anything. We probably do. Position.x plus linear velocity.x, because it won't just move linear velocity.x units over, right? I don't think it will. No, and we need to return there. It might be enough. It might be enough. We don't need a semicolon. Okay, so we accidentally got stuck because we were able to go a little too far, I guess. Position.x plus linear velocity.x is less than 0. Linear velocity equals 0. But when we whip back this way, it should be okay, because that stops it, right? But this way, we should be okay if our mouse is all the way out here, hopefully. I don't know. Oh, well, this... I don't know. We should probably also say plus linear velocity.x plus is less than half box width, right? Because we don't actually want it to stop here. We want it to stop here. Okay, so now we're stopping. We're just unable to get back, but that's progress. So we're detecting if the if on the next frame we were going to move past the half box width point, which obviously is where our box would theoretically meet the edge of the screen. And then if that happens, then we set the velocity equal to 0. I think we need to do this linear velocity detection after we do these. So after we do those, that's when we decide what velocity we'd like to use, and then this thing can override them and say no. No, you're not going to get that. If it's invalid situation. Okay, now we can't move left past... yeah, so linear velocity needs to be multiplied by something. I think the mass, maybe? I don't know. I don't think it could be the mass, because then I feel like we'd be moving barely at all, but we can try it. Because we're not just adding linear velocity. We don't just always move linear velocity units over, right? We move linear velocity times something. Maybe the mass, I don't know. No. Not the mass. What? Linear velocity. So what we're trying to do is we're trying to assess if this would take us past half box width. But currently it's a little bit too strict, right? Because we can't move left even when I'm on all the way on the right here. It thinks I'm going to move past that next frame. Because currently we're doing position.x plus linear velocity.x. The problem is that we're not actually moving the full linear velocity.x every frame. So if we multiply this by delta, which is, I believe which is theoretically pretty similar. Okay, so we're saying however long it's been since the last frame, assume that it's going to be that long to the next frame, and then calculate how far we would go on the next frame. And then if that puts us past half box width, go ahead and stop. So this works pretty well, but not as well for higher velocities. So, position, linear velocity at x times delta is less than half box width. Instead of just stopping, what I'd like to do is have us actually get pushed back to this position, right? To half box width. So whether we're past it or we're close to it, we want to stop at that position. Okay, so if we're past it, then we want to kind of bounce back. I actually just had another idea, which is what if we just put objects on the sides that kept us from going to the side. So let's go ahead and see if that works right quick. Because there's no reason to do all of this work in the script if we could actually just drop two collidable objects on the sides and then call it a day, which I think we probably can. Static body 2D. Collision object, collision shape 2D. Let's go ahead and make this a rectangle. And we're going to put it on the same height as the player, but with the edge just right there. And then, yeah, this is a static body, so that should theoretically work. Let's see if that works, keeping us from going off the left side. And it does. So there's no need to do all of this work in scripting when we can literally just do this. And it just, yeah, it just actually works super nicely. Okay, so let's, this could be called left edge guard. And the reason I made it so small is because I don't think we want, okay, let me 0 this thing's position so that the parent has the transforms. The reason I made it so small is because I think we still want objects to fall off the side of the screen, and so if this is small, then that won't interfere. If it went all the way up the side, then the sides would obviously basically be just hard sides, and the other objects wouldn't fall off. But I think here we'll be okay. Let's make this a right edge guard, and okay, I would like to only move it on the x-axis, please. Thank you. Let's see if it works. No longer going off the right, no longer going off the left. If we try to get an object and throw it off the side, see if we can throw it off the side, it just has no... Okay, it's harder to throw one of these soft objects. Let's try to throw this one. Wow, okay, I'm not having much success throwing. So there is a small case where if we hit something into it, then theoretically it might stop it. But I don't think that's a big deal. And we also might be able to fix that by messing around with the collision settings a little bit. But honestly, I'm not that worried about it right now. So, player paddle is held between the left and right sides. We have some pretty good physics setting up us, allowing us to try to balance these objects. What else could we add to the game to make it more interesting? We have objects falling in. Obviously, we can add more types of objects. And it's still quite hard. Let's try actually going for it though. I'm gonna go mostly just collect stone because that's the sturdiest of the blocks, and it still was falling off. Okay, got a good foundation in the center. Okay, now we have a tile on here. Tile just doesn't stay, so we're fine. Let's just try to get... Okay, I think they could still be a little bit more friction. A little bit more friction. Let's go ahead and increase them all just like by 1.5 maybe. So the stone will have a friction of 3. The tile will have a friction of 1.5. And the wood will have a friction... Oh, I think I just changed the mass on the tile instead. Hang on. Tile will have a friction of 0.15. I was thinking that seemed a little high. And then, yeah, the wood will have a friction of 1.5. Perfect. All right, let's see what happens. Yeah, just a little bit more hold on these wood blocks, I think. I think that's good. Still, the sand blocks very slippery, or tile blocks, or whatever they are. Yeah, I think that feels pretty good. I think it feels pretty good. Okay, we just lost them all in a single swift movement. So that's something. Yeah, so the main killer is like the inertia, because if you just whip it quickly, then the objects on top just kind of fly off. Okay, so what should we add? Maybe a point system, right? Where we get some points going in there. How would we even do that though? No, I think you maybe instead of doing I don't know, because the goal is to get the highest tower, right? How can we assess when a player has won, right? Because their goal is to get a nice, tall tower. How can we assess if they have successfully gotten a nice, tall tower? Like, what's their goal? What if we add, like, a dotted line, like, right about, like, this height? And their goal is to have objects stacked up to that height. I feel like that'd be pretty hard, but I think it would definitely be achievable. And in order to check that, we would probably have to have, the player is probably going to have every time an object hits them, probably going to have to start listening for every time an object hits that object, and so on and so on. The other option is if we put like a block up here, an invisible block up here, right? That block could detect what blocks are inside of it. And any blocks that are inside of it, if there's a block that's inside of it that's stationary, that means that the player has successfully built up a tower to that height. And so then they've won. So let's try that approach first. So here's what I'm thinking. We add... I don't want it to be a collision exactly. It's more like a trigger. How do we do a trigger? Maybe it still classifies as a collision. I'm not sure. We basically want like a trigger box. Trigger box Godot 2D. We just want like a sort of trigger box up at the top that will detect what bodies are colliding and if any of them are an area node. Okay, cool. Of course, area 2D. Okay, so our area 2D node will be placed up here at the top, and it will just monitor everything inside. So let's see. I think we need to add a collision shape as a child of it to define the actual shape, which of course the shape is just going to be a rectangle. And it should be quite a large rectangle that goes the entire width and whatever height we select to be the goal. Okay, that's a too low of a goal. Let's set the goal at around here, and then we're gonna need some kind of visualization. Win detector. Okay, so this is the area that will detect if we've won by detecting if there are any blocks inside of there that are stationary. And then we just need like a little something to show that that's the goal. Probably just some standard sprites, and we'll make like a dotted line. Let's go ahead and add a node 2D to hold these sprites, because we're just going to make like a dotted line. Actually, we could also potentially do it with text. Hang on, one more idea. Text. What is it called? Label, I think. There we go. Label. Let's add a label. And then inside of the label, I just want to make a dotted line. That's perfect. Perfect. And then this dotted line will just show the player whether they have achieved their goal. And let's see how it looks in game. Okay, I think the dashes could be a little bit bigger. Let me delete these two extra things down here, by the way, while we're at it. Win line. Okay, so in order to edit the text, it's kind of a weird setup, guys. You have to go into theme overrides, and then fonts or font sizes, and you can change the font or change the font size. And here, what we want to do is we want to change the 100, 1000. Okay, that seems probably was too big. Yes, that's a bit too big. Okay, what did 100 look like? 100 looks pretty good. Let's try that. Let's put the bottom there. So as soon as they, yeah, like right about there. So as soon as they like cross into the line, that looks okay. There we go. That's pretty clear. I think that's pretty clear what's going on. Let's just we have a few too many now. It still sticks off for a very long time. I don't know why, but we now have this, and then let's just make sure that these are kind of positioned pretty decently. So I feel like if it's half on, we're having trouble with it being half on. So I want it to look good at both sides. So if it's just a little bit on at both ends, hopefully that looks okay. Yeah, I think that looks pretty clear. It's pretty clear what's going on. That color may not be the best, although it might look a little bit better if we change the background color to black, which you can do by going to somewhere in here. I think it's there we go. Boots, no, not boot splash. Rendering, no. Environment. You can change the basically the background color of literally everything. And there we go. Now we have a pretty clear objective, I think. I think it's a pretty clear objective. And our goal, yeah, is just to stack up objects to get to that line. And we haven't actually implemented it, but I think it's possible. Honestly, if you really wanted it and you didn't want to do any work, you could probably just AFK it, just sit here and wait for enough blocks to stack up to make the line. But sometimes blocks come in and wreck your structure, so that may not be the best strat, but probably shouldn't have built that on a foundation of tile. Anyway, we now have this set up, but we don't actually have it detecting if we've won. So what we need to do is add a script on here. Of course, we need to put it in the scripts folder, and we'll call it win detector. Create that. And what we need to do is we need to, every frame, I guess, get overlapping bodies. So let's loop over the overlapping bodies. So let's say for body in get overlapping bodies. If body dot let's say the body is a rigid body 2D guaranteed. I'm not sure if that'll break it, but if body dot linear velocity dot length is less than, so we don't want to check if the linear velocity is equal to 0, because it's unlikely that the linear velocity is going to be equal to 0. We just want to check if it's a fairly small value, which means that the object is fairly stationary. So for now, let's try if it's less than 1. I'm not sure if this will work, but let's print U1 exclamation point. And let's see if that's reasonable. Also, they are spawning a little low, so I would probably like them to spawn higher so it doesn't look as... It's not clear they're spawning. We probably want them to spawn out of frame. Okay, let me... yeah, there we go. Okay, let's see. How can we cheat this to actually test this? Maybe just move the player up. Yeah, let's just move the player up to here. That should allow us to test this pretty easily. We just have to get 2 woods or... Okay, 1 stone and 1 correctly placed wood. Can you knock over, please? Ugh. No. But it was good that that didn't trigger it. So we may be on the right track, because that stone that was almost still didn't trigger it, so that's good. Just drop me 1. Just drop me 1. Just drop me 1. That's nice. That's nice. And it waited until it was pretty steady, and then it said, and then it starts saying you won. So I think that's perfect. I think that's perfect. We just happened upon a pretty good value there. So then the only thing we need to do, now the player can actually achieve the goal, and they know what the goal is, hopefully. I think all we need to do is just show, like, do something when they win. I mean, we can throw a pretty text over. Let's see, win text. And then we'll just type in you won. Maybe not all caps. You won exclamation point, and then let's just put in a nice font. Theme overrides, fonts. We can actually change the font if we check this. But okay, we have to just put one in here. New font file should be fine. Not font file, system font. New system font. And then we can select any of the system fonts by clicking add element. And then whatever we want. So I think pretty standard, like Arial Black or something should be fine. And then we just want to change, we can go to font size and change the font size to like 1,000 or something. A little bit too big. Let's try 250. Still a little bit too big. Let's try 175. Not bad, not bad. Then we'll just, let's change it to centered just so we can get the centering easier. Centered. Horizontal alignment, center. Vertical alignment, center. Okay, that didn't do anything. Because it's not over on there. Alright, we'll just do it by the eye, since this is just a quickie minute. Oh, and we have the dashes to help us out, actually. So, the dashes, right? 3 dashes on each side and just a little bit extra. And then we'll put it just below the line there. There we go. And then we'll just make it not visible. And then this script, we can go ahead and say at export variable win message of type node 2D. And then inside of this, we'll just say win message dot visible equals true. Okay, and then all we have to do is actually assign that. So win detector area assign. Okay, it's not a node 2D, so we can't say it's a node 2D. We have to say, what is it? Well, let's just say it's a label. That's fine. And we didn't actually assign it. Okay, perfect. So now if we win, it should give us the big fat U1 text. Dang it. Nope, come back. Oh, that's not good. Oh, because our blockers are low. No need to worry about that. It was just because our blockers are low. We use manual blockers, so no need to worry about that. We don't have to worry about it. The blockers should still be working fine lower down, but we just need to test this right quick. Okay, close. We just need one more to spawn on us. On a good, yeah. and that was a win, I think, because it was diagonal. So I think that's a fair thing to say. Well, that's weird that those are in front and this is behind. We should probably make sure the U1 text is in front of everything. Win text. Let's go ahead and set priority, perhaps. Not that. We need to be on the win text. Ordering. There we go. Ordering Z index. Let's set it to 1000, and that should make sure that's overlapping everything. And then I think the last thing left to do is we probably just want to make sure that the objects spawn a little higher, so it's not so clear that they're spawning. Okay, we did not get a U1. Okay, nice. It is now over the blocks and everything, so we are in good shape. What's this warning? Only affects the drawing order? Okay, that doesn't matter. I don't know why it thinks... Why is it warning me with that? Okay, it just really wants me to be warned of that. But anyway, that's working. So all we need to do is make the block spawn a little higher. So let's set block.position.y to in the spawn blocks thing, block.position.y to -10 maybe. Okay, close, but not quite there. Let's just go ahead and set it to -30. Yeah, they're now fully off screen and we just see them kind of hop in. Okay, and then the last thing we have to do is actually put our player back down to where they're supposed to be and probably put them in the center just so it looks a little nicer. That looks weird. Wait, let me just check and make sure it looks okay on start. Oh, well, on start it pretty much immediately puts it wherever your mouse is. Okay, let's try to beat the game. Also, let's make sure that our blockers are in place. Good. Oh, screw it. I'll just check this blocker. Okay, perfect. All right, let's try to beat the game, mostly using the AFK strat. See if we can pull something off. Okay, not quite. Maybe I should knock this over to make a more stable base. There we go. They did it for me. Okay, that's a pretty good one. No. Dang it. We lost him. Oh, that's nice and tall. Nice and tall. I don't want to move now because I know I'm going to knock it over. We can do this. Once we finish testing this, we can. I'll build it and put it in the description so you guys can download it if you want. Well, I'll probably just put the project files in the description so you can actually download them and mess around with them, not just to build the game, because that would be pretty much pointless. Okay, we've got 2 here. That's 3. Not bad. Oh. Okay, I'm just gonna trust that it works at this point, because we tested it with the player paddle higher up. There's not really any reason why it wouldn't work, right? So, yeah, let's just go in. Oh, the only thing I'm wondering, though, is, can you do that? Yeah, you can, and that's not good. It's not good at all. We need to find a way to turn that off, I think. Project settings, window. Mode windowed. That's fine. We don't mind it. Oh, yeah, turn off resizable. Okay, that was pretty quick and easy. Let's just make sure that they can't resize it now. If we go down here, no resizable. Okay, nice. So now they can't resize it to, I don't even know what they would do, but just really just makes it look ugly, so. We should be good. Well done, everyone. We just got a game done in, what is it, we just got a game done in like less than 2.5 hours, like 2 hours and 15 minutes or so. So yeah, good work. We got a random idea from ChatGPT. We executed the idea, and yeah, it's pretty good. So I'm gonna throw it in the description. But yeah, that should just about do it for tonight. Guys, do make sure, if at all possible, that you come to the stream next week. 7:30 p.m. Eastern, whatever time this one started at for you. Well, maybe a little earlier because I was kind of late, but try to make sure you really tune in next week. It's going to be very, very important. And that's all I'll say on that. The project files will be in the description momentarily. Have a good night.